Okay guys, so now we'll have a short look on how to build a distribution or create a distribution version of our application. So let's get into it. If I go to our application here, you may notice something apart from that there are no emails or anything in my inbox. And that is that we no longer have a port number, which is interesting because we used to have a port number. So why don't we have a port number, and why don't we see any data when I'm trying to use the application? Well, that's an excellent question. The answer is simply that I'm running a production version of my application, or of this application that we built together. And the idea here is that this is not the only way to create a production environment, but this is probably the way that most modern companies will do that. And Docker, you may know about this tool. Docker is a very, very popular tool, and it's used for quite a lot of things. Now, as a disclaimer, this is not the only way to do this. Traditionally, you could have other ways of doing this. You could manually do a lot of things, and we could have a look at this as well. But I figured that let's just keep things to tools that you are more likely to face when you're building something like this, right? But if there is a demand, we can make a video about how to do these sorts of things with actually either SSHing into environments and uploading the files manually, or using something like Chef or Ansible or whatever you're using in order to handle your environments. Anywho, as you can see here, what we're doing basically is that we're running this little cluster of services. And so we have our application, which is fmail app, and then we have Redis, MongoDB, and Elasticsearch, and they're all hooked up, and they're all exporting ports to my environment. And they're also, because they're running on the same network, they are all able to actually connect to each other, which is great. So let's have a look at how this actually looks in code. So the first thing I've done is that I've added a docker ignore file, and the idea here is basically that when I build my application, I don't want to include certain things. I don't want to include my node modules. I don't want to include my generate scripts, because I don't use them in production. I simply use them for creating fake data. I don't want to include the README, my config files. I don't want to include the Docker file or the Docker Compose YAML file. And I also don't want to include any of the tests that I've written for my code. So that's like the reason why I have that. And in my ignore file, I've just added, well, I can revert this because I don't have this directory actually. Anywho, let's look at the Docker file. So this is a basic Docker file where basically what we say is that, hey, from the base image of Node, which is going to be the latest image, just grab that as a base image. And I don't think that it's a little bit out of scope to define exactly what this means and how Docker works and so forth, because that's an entire different video series in of itself, and there's tons of content about that. But basically all I'm asking for is a Docker image that will have, or rather I want to be able to create a container that is going to have Node in the runtime or in the environment. And then I copy everything in the source directory, or the current directory I'm in, into the root/fmail folder inside of the container. I set my work directory to fmail, which is going to mean that I'm going to be in the context of this directory when I start executing commands, or when I try to go into this running container. And I expose my port 443, which is the default port for communicating over HTTPS. And then I run an npm install with the production flag, which is going to just grab the dependencies from my package.json file and exclude all my dev dependencies, because I don't have any reason to have like Jest and all the other stuff that I use for development in production. There's no point in that. And then the default command is set to node server.js, which is basically just going to start the server, right? And that's basically it. So if we have a look, I did a few things in the package.json file as well. We've added a few scripts here. As you can see, we have a build script for CSS build, which is basically just me copy pasting the watch script, but removing the watch flag because I want to be able to create a build without watching the file system. And then I have a Webpack release script that is going to run Webpack with the P flag, which is just setting this to like making this into a production build. We can optimize this even further, but optimizing our Webpack bundle is a little bit out of scope for this as well. But this is at least the basics of creating a production build with Webpack. And then I have this little script here, build production, and it's just going to run npm run build, and then npm like the Webpack release, and then it's going to run docker build, and docker build is just going to do docker build -- tag fmail. So this is the way that I would, if I wanted to just build a container from my terminal, I can do that. But for the most part, you're just going to use something like Docker Compose to do this. But this is just a convenience thing I add for my own sake. And then we have Docker Compose, where there's a few things that have happened. I've removed some lines here, but that's not so important. This is the important part. So now we have this app service, and we're going to declare build, which is going to be in the current directory. So basically that means that we assume that whoever runs Docker Compose is going to be in the context of this directory here. And then when we run this script, we are going to bind the ports so that we expose in the port 443 and basically connect that to the container's exposed port so that there's a connection between my computer and the container, so I can actually access the container on port 443. And then we have the environment, and here we set our environmental variables. So we set Mongo's URI to MongoDB, and this is now our host name, because what Docker Compose will do is that when we connect our containers and we start running them together as a cluster, that cluster is going to have an internal network. And because the amazing people working on Docker have done a really great job, our host file, which is the place where your computer is going to look to resolve the different DNS, I could do DNS resolution to start off with, or try to figure out like what you're actually trying to access when you input a domain name. That's actually going to have the name of the corresponding service. So if I have a service called DB, I can actually, if they're on the same network, I will actually have that injected in my host file. So I can just say this, and the IP address of my Mongo instance will actually be resolved for me, which is really cool. And then I set my port to 443 because, hey, that's the port I want to run my application on. And I set my Redis port, my host to Redis, because this name maps perfectly to my service name down here. So it's going to be resolved to the correct host, which is great. And then we have the same thing going on here for Elasticsearch, which is the search is going to be resolved to this instance here. And then I set my port number. And that's about it. And then we have our volumes. So what I've done here is that I've bound my temp folder on my own file system on my own computer to the temp folder on the running container. And the reason why I want to do that is because I've added some basic logging just to do some type of logging of like what's happening in the system. We'll talk about that in just a moment, but that you should know that if you don't know this. So when you start a Docker container, everything is running within the context of that container. But if you want to expose something and persist something for longer than the lifespan of that container, you have to bind it to a volume of some sort, either on your own computer or if you're running in the cloud to one of their file systems. And the reason for that is because as soon as you kill the container, all the data is gone. And that's exactly what happened with our application here. You saw that there were no emails anymore. And the reason why is because I've simply killed off this instance. I took down my Mongo instance, and since I'm not binding the files, or rather the actual file that stores all my data that Mongo, like the running MongoDB server, is actually outputting to the file system, I'm not binding that to my own computer. I lose all that data as soon as the image is gone. So if we wanted to, because I don't feel like I need to do that for like development like this, but if you want to be able to save your data long term, you have to provide a volume bind to your own computer basically. And that's what's happening here. So Then we finally have this depends on clause here, which is just going to state that, all right, don't start this application service until these services have already started. So these things in all my databases need to be up and running before I actually connect to them. And that's about it, really. Let's look at the server. So in the server, I just added a little bit of a unhandled rejection clause here, or like a catch for that. So basically what this means is that if the server throws an error for some reason, like an unhandled promise rejection or something like that, I'm simply going to catch it here, because this will be safe, because we have that catch exception or catch error function that we used in a previous video to wrap all of our routes. But connecting to a database can still fail. So what I want to happen here is, if let's say MongoDB isn't actually up and running, and there can be, like, we can't establish a connection, then there's going to be an unhandled rejection. And I want to catch that here and just exit if that happens. Right. Then we have our app where we've added some logging. Let's have a look at the logger. So I created a logger, and now I have like just a basic logger for the error that might occur here. We can clean this up a little bit. It's not super nice, but hey, we don't have to go crazy now, do we? So here is our logger instance, and I use Bunyan for logging, which is pretty great, where we can create a stream. And basically there are several streams, and Bunyan is a fairly big tool, but for the most part you'll be fine with using something like this, where you declare a rotating file type, which basically means that for 24, like for the time duration or the step size that you decide, or the period, you're going to log to one specific file, and then you're going to log to a secondary file, and then a third file, and then you're going to rotate for count amount of times. And I've declared a log level of info, which means that info and everything below it will be logged to this, which basically is like, I can log levels is a different type of topic, but just basically the different log levels. Info is like the highest level, so everything below it, down to debug, like error and all that stuff, is going to be logged out to this log file here. And I've set a period of 1 day, which means that every day we're going to rotate to the next file, and then we're gonna, and finally I set a count of 7, so 7 days, and then it's gonna roll over and start again. And the reason why you want to do that and just not write everything to one file is because that log file is going to be absolutely massive after a little while, and you're not going to be able to, to use it effectively. So this is just a nice little thing you can do. And then we have a bunch of log statements here. So let's just look at one of them. So logger.info, and basically all I'm logging out now is that this is a GET request, the URL, and then the parameters that I'm actually extracting from the query here together with the user session. The reason why I like to do this is because when you're working and there's an issue with the system for some reason, it's very useful if you can figure out what actually came into the system when there was an error. So logging out the endpoint and like the user ID, so you can know which user hit what endpoint with what input, is going to be very helpful. Think of it as very much as a function. When you're debugging a function in your code, what's useful for you to know is the input and the output. I haven't added anything for the output because you don't want, and especially not for in info, you don't want to have like an info log that's going to run for every request on what's going to come out of the system. That could be useful to have like a debug level or something like that, or you could do info if you really, really want to know what's coming out. But for most of the time, I think that this is the basics. Just having what's coming in, that's a good start. And on a personal level, I also like to log what's coming out, because if I know what came in and what came out, it's easy for me to reason about what went wrong in between. Anywho, these are all the same basically. I'm just going to scroll through them, and they're just declaring different, the inputs and so forth. There is one thing we need to touch on, but not in this file, so we will have a little bit of a look at that later on, or rather just in a moment here. This is something we may need to talk a little bit about. We're logging out recipients, subjects, and message. Now, thanks to a law that has been passed not that long ago called GDPR, this may or may not be a problem, because if you think about it logically, GDPR states that a user needs to be able to be forgotten, and if you are supposed to not store any personal information about a person or any type of sensitive information, basically, this might be a problem, because if you're logging out, say, recipients, then technically what you are doing is that you are, in a way, in that log file, you're storing who the person using your application was sending the email to. Subject and message could, in theory, contain personal information about the person who's using the service or somebody they know and so forth, so that's a little bit of a problem area. We don't have to think about this now because this application is not going to go out and start making money or anything like that, but it is something you should be aware of. Logging can be a very tricky thing if you're not careful with what you classify as personal information. And then we have user routes, where what we're doing here is that we're grabbing the email and the password. And in this scenario, we're simply going to log out the length of the email and the password because, hey, we don't want some log file on the file system, because remember, this is not hashed information. In other words, this is just plain text, and that's a big no-no. If we have a log file with the person's email and their password, well, then that entire user's account and all the content they have on our system is going to be compromised if a hacker could get into the environment, right? Cool. So yeah, that's basically it. This is more or less it's a fair, there's so much more you could be doing if you want to, depending on how complex you want to make this application, but this application is in a fairly good state to be able to run on the internet and be production ready, I would say. There are things we could add, but for now this is absolutely good enough. Anywho, we will simply say that, hey, for now, this is a distribution, and that's pretty much done. And in the next video, we're going to have a look at a bit of automated testing. So let's get into that.